Hi, good day everyone. In today's Fun with Physics, I am going to tackle about density. Density is defined as a measure of mass per volume. It has the SI unit of kilogram per cubic meter. Facts about density. First, Eureka moment. The Greek philosopher Archimedes was given the difficult task of finding out if King Hero's goldsmith was stealing gold and replacing it with a cheaper metal in a valuable object. Archimedes realized while taking a bath that he could determine the volume of the suspected object by the amount of water it displaced. Then, by dividing the weight by the volume, then comparing the resulting density with that of gold, he could determine if the object was gold or a cheaper substitute. According to legend, the thought so thrilled Archimedes, he ran through town shouting, "Eureka!" a Greek word meaning "I have found it." Therefore, after this discovery of Archimedes, it found out that different material has different density. Thus, the goldsmith cannot fool King Hero. It was also said by our junior high school teacher that Archimedes ran outside naked, shouting, "Eureka! Eureka!" Second, changes in density. Changing the pressure or temperature of an object will generally stop its density. As temperature decreases, the motion of the molecules in a substance slows down. As they slow, they require less space, causing density to increase. Conversely, an increase in temperature usually results in a decrease in density. Therefore, density and temperature has an inverse proportion. There are also exceptions to the rule. For example, water. It expands slightly when it freezes, so ice is less dense than liquid water. Ice floats on water because the density of ice is lower. For example, kanatong makita nga iceberg. Third, floating and sinking. Relative density determines whether an object will float in a liquid. For example, a tree branch floats on a river if the wood is less dense than water. On the other hand, an iron cannonball sinks into water because its density is greater than water. Keep in mind that an object's whole density plays an important role in floating and sinking. An iron ship, for example, floats in an ocean because although iron is denser than water, most of the ship's interior is filled with air, reducing the vessel's density overall. If the ship were a solid block of iron, it would sink like a stone. So, diri na mosud ang buoyancy. How can the study of density be used in the real world? In ships and submarine, one well-known application of density is determining whether or not an object will float on water. If the object's density is less than the density of water, it will float. If its density is greater than that of water, it will sink. Ships can float because they have ballast tanks that hold air. These tanks provide large volume of little mass, thus decreasing the density of the ship. Together with the buoyant force that the water exerts on the ship, this reduced density enables the ship to float. In fact, submarines dive below the surface of the water by emptying their ballast tanks. In oil spills, like ships, oil floats because it is less dense than water. But unlike ships, oil requires no special engineering. Oil is naturally less dense than water, which is why even oil and vinegar salad dressing separates, with oil floating on the water-based vinegar. Though oil spills are detrimental to the environment, the ability of oil to float aids cleanup. Thus, we are thankful that oil separates from water, because when ship leaks oil, it can cause harm for the animals in the ocean. Lastly, in plumbing systems, fluid flow through a pipe is an important real-world application of density governed by a relation known as Bernoulli's equation. Bernoulli's equation is a special use of the concept of conservation of energy, and the result is that the density of fluid affects the fluid's velocity, pressure, and even its height. All else being equal, a fluid of greater density will flow through a pipe with lower pressure, velocity, or height, respectively. engineers rely on Bernoulli's equation when they design dams and large-scale plumbing projects. That would be all. Thank you. Hope you learned something.